So today I'm gonna do a little lesson on position vector. So what is actually a position vector? Suppose there be a point P in a three-dimensional space, and that point you can see in here, it's shown by a yellow highlight in here, point P, which its coordinates is x, y, z. And we know in case of vectors, if you have a three-dimensional space, you can have z-axis, x-axis, y-axis, and in the direction of x-axis we have the unit vector I cap, in the direction of y-axis it is unit vector j cap, and in the direction of z-axis the unit vector is k cap. So these are the three unit vectors along the direction of x, y, z, which we already know. Now we are tasked here to find the position vector of the point P. So what is position vector? So position vector is nothing but a vector which represents the position of the point P with respect to origin. So it tells us the position of the point P with respect to origin. So where does the point lies with respect to origin? So that's what the position vector of that point P. So in order to determine that thing, so we know that a vector is what? It has magnitude as well as direction. So what we're going to do is, from the point origin, we will draw a line like this to that particular point P. And once we draw that particular point, so that line has two endpoints whose initial point is origin and the terminal point is the point P, and the direction is from O to P. So this is now a vector whose length will be the distance between the point O and P, and the direction is from O to B. So that is what a vector is. A vector has a magnitude as well as direction, and it satisfies that. So we have an OP vector. So this is how we denote OP vector, as O is the initial point, P is the terminal point. Now how to get that OP vector? So if you look carefully, this OP vector we need to get from the point O to this point P. So basically we need to reach this point P. Now how to get to that point? The first thing, initially we see a vector in the x-axis, that is OA vector. Now OA vector is given by what? The coordinate of A is x, 0, 0. So that's the coordinate of x. So basically I formed a cube in here with respect to that point x, y, z, and in the x-axis the coordinate is x, 0, 0, because in the x-axis y coordinate and z coordinate has to be 0 and 0. So if you have to tell that what is OA vector will be, so OA vector will be x I cap. So this is my OA vector. Now there is another vector along the terminal point of OA vector is nothing but the initial point of OB vector. So by triangle law of vector addition, we can add these two up, and the resultant of these two vectors is nothing but the third side of the triangle. So OB vector, just like OA vector, it is given by y j cap. And why is that? Because it is parallel to this line, this vector. So the length will be y, the magnitude will be y, and the direction is j cap because it's along the positive direction of y axis. So it is OB vector is y j cap. Now if I find the resultant of these two vectors, the resultant is given by a vector that is this one. Oh sorry, this is not OB vector, this is AB vector. This is not OB vector, my bad. It will be AV vector, because the initial point is what? A, and the terminal point is B. That's AB vector. Now the resultant of these two vectors gives you OB vector, and OB vector is what? OB vector we know by triangle law of vector addition. By triangle law of vector addition, we can say that OB vector is nothing but OA vector plus AB vector. So OA vector is equal to x I cap and AB vector is equal to y j cap. So by this way we got OB vector, and once we get OB vector, through that we can reach the point P. And how is that? If you look at here carefully, now we have another vector BP vector. So you have OB vector and then BV vector, and again the same thing, the direction of OB vector is in this direction. It is in this particular direction. So the terminal point of OB vector is same as the initial point of BP vector. So again we can apply the triangle law of vector addition. So we can write that OB vector plus BP vector. If you add OB vector and BP vector, and what is BP vector actually? So BP vector is nothing but it is parallel to this one. It is parallel to this thing, BP vector. It is parallel to this one. So BP vector is equal to Z K cap. The direction is along the Z axis, that's why K cap, and the magnitude is Z, so it will be Z K cap, right? So this is how we got BP vector. And so once we get BP vector, again we're gonna apply the triangle law of vector addition, and we can do BO vector plus BP vector, and that gives us OP vector. So BO vector is how much? We already found out from here, that is xi cap plus yj cap, xi cap plus yj cap, and BP vector is nothing but Z K cap is equal to OP vector. So this is how we find a position vector of any given point in a three-dimensional space, xi cap plus yj cap plus zk cap. So that is how we do it. So this is a broader one. Now if you just have to understand in a shortcut way, so what we can say is that this OP vector is nothing but vector joining 2 points. OP vector is nothing but vector joining 2 points, because O origin is also a point and P is also a point. So whenever we have to find vector joining 2 points, the thing which we do is, by shortcut method, it is terminal minus initial, the coordinates of the terminal point minus the coordinates of the initial point. So the coordinates of P you see x, y, z, and the coordinates of O you see 0, 0, 0. So the terminal minus initial, x minus 0 I cap, because it's in the x axis, then y minus 0 j cap, y axis, plus z minus 0 k cap. So we have x I cap plus y j cap plus z k cap. So this is how we find position vector of any given point. And for an example, you can have here, suppose you are asked to find the position vector of a point A which has the coordinates as 2, 4, 5, then the position vector will be given by OA vector is equal to 2i cap plus 4j cap plus 5k cap, and sometimes position vector can also be written as small a vector. So this is how we find position vector